This question says, find the power that is absorbed or supplied by the elements. So we have a circuit diagram, and we want to find the power of each element of this circuit. We know we have 3 different elements. I'm going to start with this element right here. I'm just going to write the equation for power. We know power equals current times voltage. And the reason why we're going to use this equation is because we don't know the resistance of any element in this circuit. Now, when we look at this circuit, is this a series or a parallel circuit? We know this is a series circuit, which means the current is going to be the same in each one of these elements. Now that we know that, the current in our first element is going to be 2 amps. And because of the direction of the arrow, we know the current is going to flow from the positive terminal to the negative terminal. Therefore, this is going to be a positive current. So the power for our first element is going to be a positive current, which is 2 amps, multiplied by the voltage, which is 8 volts. When you multiply 2 times 8, you're going to get 16 watts. And because it's a positive power, we know this element is going to be absorbing power. So I'm just going to write absorbed. So this is the answer for our first element. Okay, now let's look at our second element, which is going to be a dependent source. This is a current-controlled voltage source. So the voltage therefore depends on the current, and in this situation that current is going to be Ix. So what you can do is you can solve for the voltage by plugging in the value of Ix. Now in this circuit it's very easy because they give us what the current Ix is. We know the current Ix is just going to be 2 amps. So when we solve for the voltage for this dependent source, we can just write back 2. And we know Ix is going to be 2 amps. So we're going to say 2 times 2. And that's going to give us 4 volts. Therefore, the voltage across this voltage source is going to be 4 volts. Therefore, let's write the equation for power. The power across this dependent source, 2Ix, equals the current times the voltage. We know the current in this particular situation is going to be a positive 2 amps because the current is flowing from the positive terminal to the negative terminal. So we're just going to write 2. And the voltage across this source is going to be 4 volts. So we're just going to write 4. Therefore, the power in this dependent source is going to be 2 times 4, which is going to give us 8 watts. And because it's a positive power, we know that element is going to be absorbing power. So I'm just going to write absorbing or absorbed. So this is our answer for our second element. Now for our third element, we have a 12 volt source. I'm just going to write the power of a 12 volt source is going to equal I times V. Now we know I in this particular situation is going to be 2 amps. Now when we look at this particular element, it's important for us to always remember if the current is flowing from the negative terminal to the positive terminal, we're going to treat it as a negative current. So because we know the current is going to come around and it's going to come this way and go in that negative terminal, we must write our current as negative. So we're going to say the current is going to be negative 2 amps and the voltage is 12 volts. When you solve for this, the power in the 12 volt source is going to be negative 24 watts. Now because it's a negative power, we can say this is delivered. Now remember, for power conservation, the power delivered must equal to the power absorbed. So we have 16 plus 8, that's going to give us 24 watts absorbed equals 24 watts delivered, which means the power conservation is satisfied. Let's do another example. So we have this example here, and they want us to find the power in each element. So we're going to start with this 24 volt source. We can say the power in this 24 volt source is going to equal to IV. Therefore, let's find the current. We know this is a series circuit, right? So because this is a series circuit, the current in each one of these elements are going to be the same. Now we don't have a current source, but on this diagram, we have a current that it's labeled, and that current is going to be Ix equals 2 amps. So because we have a current, and this is a series circuit, we know this current is going to be the same for each one of these elements. Therefore, we can say that the current is going to be 2 amps. But when we look at this, we know the current is going to be flowing in this direction here. When we look at this, the current is going to flow into this source, starting at the negative terminal and then going to the positive terminal. Because that is the case, this is going to be a negative current. So we're going to write negative 2 amps for the current, and the voltage, we know that's going to be 24 volts. So when you solve for this now, the power in this 24 volt source is going to be negative 48 watts. And we know because it's a negative power, that means it's being delivered. This is the answer for the 24 volt source. Alright, let's find the power in this element. So we have the power in the power in the first box. Now we don't know whether it's a source or whether it's a resistor, but when we calculate the power, we'll be able to tell whether it is a source or whether it is a resistor. Now, we know the formula is going to be current times voltage. Therefore, let's substitute in the values. The current in this particular situation, we know is 2 amps, and we know that is going to go this way, right? So we know the current is going this way. Therefore, the current is going to go from the positive terminal to the negative terminal, which means we're going to treat this as a positive current because it's going to go through the positive terminal. So we're going to have 2 multiplied by the voltage, which is 40. When you solve for this, the power in the first box is going to be 80 watts. And we know that's going to be absorbed. Okay, let's do the power in the second box. We have the power. The second box is I times V. We know the current is going to be 2 amps and it's flowing from the positive terminal to the negative terminal. So we're going to have a positive current of 2 amps and the voltage is going to be 12 volts. When you solve for this, the power in this box is going to be 24 watts. Therefore, because it's a positive power, we know it's going to be absorbing power. So this is the answer for that particular element. Now for our fourth element, we have a current controlled voltage source. So we want to find this variable, Ix. We know Ix is 2 amps. So we're just going to substitute 2 amps into this equation to find our voltage. Therefore, we can write this as 4 times 2, and that's going to give us 8 volts. So we know this source has a voltage of 8 volts. All right, now let's write our equation. The power in the dependent source is going to be I times V. We know the current is 2 amps. But when this current travels through this particular source, it's going to go through the negative terminal and then the positive terminal. So this is a voltage rise. Because we have a situation like this, we're going to have a negative current. So we're going to say -2 times the voltage, which is going to be 8 volts. Right? So when you solve for this, you're going to get -16 watts as your answer. And because this is a negative power, it's going to be delivered. Now, I made a slight mistake. The voltage for this particular box is 20 volts, not 40 volts. So I'm just going to change this to 20 volts. And 2 times 20 is going to give us 40 watts. Now, when we look at Telegin's theorem, we have -48 watts plus 40 plus 24 plus -16 watts. That's going to give us 0. Therefore, Telegin's theorem holds true.